So chapter 1 is math review. So starting with the two number systems that we'll be using, we have the Hindu Arabic system and the Roman numeral system. So for the Hindu Arabic system, this is the number system that we use today that we're familiar with. It uses the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and a mixture of those with an understanding of the place values to describe different numbers. For the Roman numeral system, is going to be another system using these letters written down here. We have SS, which is 0.5 or 1/2. We have I, which represents a 1, V, which is 5, X, which is 10, L, which is 50, C, which is 100, D, which is 500, and M, which is 1000. And using different combinations of these letters, we can express the numbers that we need to write down. So there's obviously certain rules that need to be followed here. We can either use capitals or lowercase letters, but we can't do both of them at the same time. The only fraction that we can write using this system is 1/2, or the 0.5, which is the SS. And whenever a 1/2 is involved using the SS, that's only written with lowercase. So whenever we have 0.5, everything will be lowercase letters. So here are some of the rules here and how we do this. Starting down here with this first bullet point. So letters may be repeated, but never more than 3 times in a row. When a smaller number is in front of a larger number, we subtract the smaller from the greater. And with the exception of the above subtraction rule, we're going to add all of the values together, and only one letter at a time can be subtracted from another. So following these rules, let's do these examples down here. So let's write the Roman numerals as the Hindu Arabic numerals. For A, we have the number XVII. So X is a 10, V is a 5, and I is a 1. So there is no smaller value preceding a larger value. It goes in decreasing order here, so all we have to do is add these together. So we get 10 plus 5 plus 1 plus 1, and that gives us 17. So XVII is the number 17. So next for B, we have CD. So C is 100 and D is 500. Since C is smaller than D and it's before it, we have to subtract it. So that's 500 minus 100 because C was smaller than D here. So subtracting these, we get 400. For the next one here, for C, we have LIX. So L is 50, I is 1, X is 10. So 50 is the largest here and it's first, so we're going to be starting with that one. However, for the next one, we have IX. I is 1, X is 10. So 1 is less than 10. So we have to actually subtract 10 minus 1, and then we're going to add that result to that 50. So it's going to be 50 plus 10 minus 1. So you have to make sure your order of operations are correct here. We have 50 plus 9. So we get 59 is our result here. So in this case, the order of operations wouldn't have actually hurt you, but just do the 10 minus 1 first, and we get 9. So 50 plus 9, we get 59. Next one for D, we have XCIV. So this one is in lowercase, which is fine. They mean the same thing. So X is 10. C is 100 and I is 1, V is 5. So I'm just going to write this below it. So X is 10, C was 100, I is 1, and V is 5. Okay, so we have, looking at these first ones, we have 10 is less than 100, so we have to subtract it. And 1 is less than 5, so we also have to subtract that one, and then we add those together. So we end up getting 100 minus 10 plus 5 minus 1. So we get 100 minus 10 is 90, plus 5 minus 1 is 4. So 90 plus 4, we get 94. So don't make the mistake here of subtracting more than you have to. It's just you subtract these two separately, add them together, and you get 94. Okay, last one here, we have IISS. So I is 1. The SS as a whole is 0.5. So we are going to have 1 plus 1 plus 1/2. We add them all together because it's in decreasing order in terms of the numbers. We don't have to subtract anything. So this gives us 2 and 1/2. So this is a mixed number here, which we'll be getting into. You can write that as 2 and 1/2, or you can write that as 2.5. Okay, so let's go the other way here. Let's write these Hindu-Arabic numerals as Roman numerals. So we want to write 63 using Roman numerals. So to do this, it's usually good to start with one digit at a time, starting with the left. So 63, let's think about 60 first. So let's think about how we get to 60. Well, we have our letter L, which represents 50. So if we do LX, LX represents 50 plus 10, which is 60, right? So now all we have to do is add 3 more. So to do that, we have to just add 3 i's at the end. And we get LXIII is 63. And obviously double check that working backwards. L is 50, X is 10, which is 60, plus the 3 i's, so 63. So next for the 4. So for the 4, we have to make sure that we're not accidentally putting 4 i's next to each other. That would be wrong because we can only have 3 letters in a row. So what we have to do is think backwards from 5. So if we have a letter 5, that would be V. And we have to subtract 1 from 5. So that means we're going to be using an I. We have to put the I before the V, indicating that it's subtracting. So 4 would be IV. Once again, think backwards, double check. IV, the I is 1, the V is 5. 1 is before the 5, so we subtract. 5 minus 1 does equal 4. Next one here, we have 48. So we do have to be careful here. It's really easy to try to write 48 as IIL, meaning we have 2 and we have 50. The 2 is in front of the 50, so it's 50 minus 2 is 48. However, we can only subtract 1 letter or 1 number at a time. So this would not represent 48, so this would be wrong. So what we have to do first is get 40 and then add 8 to that 40. Well, to get 40, that's going to be XL. So this represents 40 because it's 10 and 50. It's 50 minus 10, which is 40. And now we have to add 8 to this. So adding 8, we know that 8 is going to be VIII. So if we put a VIII at the end, that's going to be adding 8. So that gives us 48. Next one here, we have 125. So for this one, you're going to want to get 100 first. So 100 is C. and then you're going to want to add 25. 25 in Roman numerals is going to be xxv because it's 10 plus 10 plus 5. So we just have to add that after. So we get cxxv is 125. And lastly here we have 39 and 1/2. So let's get to 39 first. So getting to 39, let's get to 30. Getting to 30 would be xxx. So this represents 30. Now getting to 9, that's going to be ix. And I'm using lowercase letters here because we have 1/2. So we're going to have a lowercase ss. So everything has to be lowercase. So far this is 30 plus 9. So 39. And then to get the 1/2, we just have to include the ss. And we get that 39 and 1/2 in Roman numerals is xxxixss. Okay, so that is the two number systems that we'll be using. Next, for some fraction review, we'll start by reducing fractions. So every fractional answer that we have should be in reduced form or simplest form. And we say that a fraction is reduced when there's no common divisor or common factor of the numerator, which is the top of the fraction, and the denominator, which is the bottom of the fraction. So what we can do here is we can think of this as dividing off a common factor in the numerator and denominator. So let's see an example here. First one, let's reduce these. First one is 10 divided by 15, or 10/15. So both of these have a common factor that we can divide off. They both have a common factor of 5, the 10 and the 15. So we can divide them both by that common factor. And 10 divided by 5 is 2. 15 divided by 5 is 3. And now 2 and 3 don't have any common divisors, so we're done. 10 over 15 reduces to 2 over 3. Next one, we have 24 over 30. So we want to think of a common divisor here. And the greatest common divisor here that they're going to have in common, the greatest common factor, is going to be a 6 between 24 and 30. So we divide numerator and denominator by 6. 24 divided by 6 is 4. 30 divided by 6 is 5. So we get 4 over 5 is our reduced form. We can't simplify it any further. So let's say we accidentally used a 2 to simplify this first, and we divided by 2. If we did that, we would end up with 12 over 15, and then we would have to realize that we could actually simplify that further, and we just have to do that again and divide by 3. So you might not always pick the greatest common factor right away, but then you just have to keep on going if you didn't do that. And last one here, we have 18 over 36. So 18 actually goes into 18 and 36. So we divide numerator and denominator by 18. 18 divided by 18 is 1. 36 divided by 18 is 2. So 18 over 36 simplifies to 1/2. Okay, so let's move on to converting a mixed number to an improper fraction. So a mixed number is like how we wrote on the first page, I believe it was. A mixed number consists of a whole number and a fraction part. For example, 2.8 as a decimal, we could write that as a mixed number as 2 4/5. We could also write that as what we call an improper fraction. An improper fraction just means the numerator is greater than the denominator. And as an improper fraction, this would be 14 over 5. So 2.8 equals 2 4/5, which is the same as 14 over 5. So before I get into those examples, for mixed numbers, if we have something like 2 4/5, what this actually means is 2 plus 4/5. It's just shorthand without having to write that addition sign. Okay, so for the steps here for converting a mixed number to an improper fraction, we're going to multiply the denominator of the fraction by the number out front and add the numerator to the product. And then we're going to place that result over the original denominator. So let's see these examples here. So we're going to convert these to improper fractions. We have 3 and 4/5. So based on these steps, we're going to multiply denominator times the number out front plus the numerator, and that's going to all be over that original denominator of 5. 5 times 3 is 15. 15 plus 4 is 19. So 3 and 4/5 equals 19/5, or 19 over 5. Do one more here, so 5 and 5/8. So we're going to multiply denominator times whole number out front plus the numerator divided by that denominator. So it's going to be 8 times 5 is 40. 40 plus 5 is 45. That gives us 45 over 8 is the same as 5 and 5/8. Okay, so hopefully pretty simple for that one. Now let's go the other way. Let's convert an improper fraction to a mixed number. So to do this, we actually have to divide the improper fraction, and we're going to record the quotient and the remainder. So the quotient is the answer, and the remainder is what's remaining when we're dividing. And then we're going to write the mixed number using this form, the quotient and the remainder over the original denominator. So let's see an example here. We have 42 over 5 for this first one. So we're going to start by dividing this. We're going to do 42 divided by 5. So the 42 is what we call the dividend, and the 5 is called the divisor. Okay, so dividing this, we have to think, how many times does 5 go into 42? Well, it goes in 8 times evenly, so that's going to be an 8 up here. And then we multiply 8 times 5, we get 40, and we subtract 40 divided by 42 minus 40 is 2. And 5 is now greater than 2, so we're done. So we have 8, which is the quotient, and 2 is the remainder. So when we're writing our final answer here, just like it says right up here, it's the quotient and the remainder over the denominator. So it's going to be the quotient, which is 8, and the remainder 2 over that denominator, which or the divisor, which is 5. So 42 over 5 is the same as 8 and 2/5. Let's do one more. We have 52 over 4. So 52 over 4, we start by dividing. For this one, we can say how many times does 4 go into 5, because 4 is smaller than the first digit here. It goes in once. 1 times 4 is 4. 5 minus the 4 is 1. We bring down the 2. And then we say how many times does 4 go into 12? It goes in 3 times. 4 times 3 is 12. We subtract and we get 0. So now we're done. Anytime we get 0, we're always done when we're dividing. So our answer here would be the quotient and the remainder over the divisor. But you would never write 13 and 0/4. We would just write this as 13. So this one, as a mixed number, actually ended up just being a whole number. We don't need the fraction portion. Okay, so next for adding and subtracting fractions. When we are adding and subtracting fractions, we need to have a common denominator. If the fractions don't have common denominators, we have to rewrite them by finding the least common denominator, or the LCD, which is the smallest multiple that both denominators have in common. And when we're rewriting this fraction so they have the same least common denominator. We have to multiply the numerator and denominator by the same number in order to get this. And then once they do have the same denominators, all we have to do is add or subtract the numerators and write that answer over that least common denominator. So let's do these examples down here. It always sounds more confusing than it actually is before we do an example. So for the first one, we have 3 over 11 plus 5 over 11. So we're adding, so we need the same denominator. We already have the same denominator here. They both have a denominator of 11. So all we have to do is we have to add the numerators together. 3 plus 5 is 8 over that denominator of 11. So just make sure you keep that denominator the same when you're adding or subtracting. You don't add or subtract the denominators. Okay, next one we have 7 over 15 minus 13 over 15. Once again, we're adding or subtracting here, so we have to get common denominators. We already have a common denominator of 15, so all we have to do is the 7 minus the 13. So this is actually going to give us a negative number. 7 minus 13 is going to be negative 6. I'm going to put the negative out front. And then 6 over that common denominator of 15. We can simplify this a little bit further. They both have a common factor of 3 that we can divide off. So divide 6 by 3, we get 2. Divide 15 by 3, we get 5. So our final answer is negative 2 over 5. So always write your final answers in reduced form if you can. Next one, we have 1/4 plus 1/2. So this time we do not have common denominators, so we have to get common denominators. So we have to find the least common multiple of 4 and 2. So we can write that out if we want. So multiples of a number are going to start with the number itself, and then you just add the number continuously to itself. So multiples of 4 are going to be 4, 8, 12, 16, and so on. Multiples of 2 are going to be 2, 4, 6, 8, and so on. So we find the one that they have in common here, that's the smallest. They both have this 4 in common, so we need to rewrite both denominators so that they're a 4. So the first one already is a 4, so the second one we have to make this 2 a 4. So to do that we have to multiply by something. In this case we have to multiply by 2. So we have to do it to the numerator and denominator, so we're technically not changing anything. So this ends up being 1/4, the same first one, I didn't change it. 1 times 2 in the numerator is 2, divided by 2 times 2 in the denominator is 4. So 1/2 is the same as 2/4. Now they have the same denominators. All we have to do is add these numerators, so we get 3 over 4. So maybe this was one that we could have done in our head if you were comfortable with it. Okay, do a couple more here. So we have 11 over 12 minus 4 over 9. So once again, we have to get common denominators here. So let's find the least common multiple between 12 and 9. So multiples of 12 are going to be 12, 24, 36, 48, and so on. And then the multiples of 9 are going to be 9, 18, 27, 36, and so on. And the smallest one they have in common ends up being that 36. So we need to rewrite both of these fractions so they have a denominator of 36. So for the first one, we would have to multiply this one by 3 over 3. And then for the second one, we would have to multiply by 4 over 4. So we have to multiply by 4 for the second one here and 3 for the first one. So 3 times 11 is 33. 3 times 12 is 36, which is what we wanted that to be. Minus 4 times 4 is 16, divided by 9 times 4, 36. So now we have common denominators, so we just have to subtract the numerators here. And 33 minus 16 gives us 17. So it's 17 over 36. It cannot be reduced any further, so we are done with that one. And the last one here, we have two mixed numbers, 3 and 2/5 plus 6 and 9/10. So what I would recommend here is always change these to improper fractions. Technically, you don't have to. I just think it's personally a little bit easier, because if you don't change them to improper fractions and you use mixed numbers, then you usually have to do a slight adjustment at the end when you get your answer. So just change it to improper fractions right now. So 3 and 2/5. I'm just gonna not show my work for this one, but it's 5 times 3, which is 15, plus the 2, which is 17, over that denominator of 5, just like we did a few pages ago, plus 6 and 9/10. 10 times 6 is 60, plus 9 is 69, over 10. And now we would have to get a common denominator. The least common denominator is going to be 10. So we're going to multiply that first fraction's numerator and denominator by 2. So we're going to get 34 over 10 plus 69 over 10. And now we can just add these numerators together. And we would get 103, 34 plus 69, 103 over 10. And this does not simplify any further. So I'm actually going to write this as a mixed number for the answer, just because our question had mixed numbers in it originally. So as a mixed number, we would have to go back and divide these. This would be 10 and 3/10 is our final answer here. Okay, because that's the 103 divided by 10, which is 10 and 3 over 10. Okay, next for multiplying fractions. So for multiplying fractions, the easiest way to do this is to cancel before we actually multiply. So we're going to be canceling, which is essentially similar to reducing. We can divide a common number into any numerator and any denominator to make them smaller before we multiply. So once we cancel these common factors, then we can multiply the numerators together and multiply the denominators together. So doing the canceling before we multiply will mean we don't have to reduce after we multiply. It'll make the numbers smaller for us. And keep in mind, you do not need common denominators when we're multiplying or dividing fractions. So let's do this first one here. Let's multiply 4/5 times 10/3. So we can multiply straight across if we want to, but let's cancel first. So canceling common factors here. We can't reduce these individually, but we can take a look at this 10 and this 5. Since one's in the numerator, one's in the denominator, we can reduce them. 10 divided by 5 is 2 over 1, because they canceled out, they had a common factor of 5 that we divided off. And now we can just multiply these across. 4 times 2 is 8, and 1 times 3 is 3. So we actually get 8/3 for this first one. So just for some practice, let's write this as a mixed number. So 8/3 as a mixed number would be 2 and 2/3. 3 goes into 8 twice evenly, with remaining 2. So it's 2 and 2 over 3. Okay, next one we have 2/7 times 7 over 2. So for this one, we recognize that we have 2 divided by 2, which is 1 over 1. Common factor of 2 canceled. Same thing over here, 7 over 7, we get 1 over 1. So this whole thing ends up being 1 times 1 in the numerator, which is 1, and then 1 times 1 in the denominator, which is also 1. So 1 over 1 is just 1. So hopefully you kind of recognize that when you saw this one right away, 2 over 7 times 7 over 2. Those are something called reciprocals, which we'll see in a second. Multiplying them together gives you 1. Last one here, we have 2 1/2 plus 3 1/5. So we have to write these as improper fractions. So unlike adding or subtracting, where you could get away with adding or subtracting mixed numbers, we have to switch these to improper fractions, which is why I just always recommend switching to improper fractions no matter what. So 2 1/2 as an improper fraction is going to end up being 2 times 2 is 4 plus 1 is 5 over that denominator, times 3 1/5 as an improper fraction. 5 times 3 is 15 plus the 1 is 16 over that denominator. And all we have to do now is we can actually simplify a little bit. 5 over 5, the 5's cancel, we're left with 1 over 1. And then 16 over 2, 16 divided by 2, common factor of 8. So we have 8 and 1. So multiply numerators, 1 times 8 is 8. 1 times 1 is 1. So we get 8 over 1. Anything over 1 is just whatever's in the numerator. So 8 over 1 is just 8. Okay, so that one ended up being a nice whole number for us. So lastly, for division of fractions, so recalling what I said a few seconds ago, the reciprocal of a fraction, a over b, is b over a. So essentially you're just flipping or switching the numerator and denominator, and reciprocals have a product of 1. So we're going to need this concept for division of fractions. So when we're dividing two fractions, the answer is called the quotient. So the quotient of two fractions is the first fraction multiplied by the reciprocal of the second fraction. So we're going to be changing division to multiplication. We're going to keep the first fraction the same. We're going to change division to multiplication, and then we're going to flip or reciprocate the second fraction. So that's why people call this keep, change, flip. So if we are if we're dividing a over b divided by c over d, that's going to be the same thing as a over b times d over c. So we changed division here to multiplication, and then we flipped the second fraction. Let's do a couple examples. So let's divide the following fractions and simplify if we can. So first one, we have 2/3 divided by 7 over 15. So as soon as you see division, we should keep the first one the same, change to multiplication, and flip the second one. So instead of 7 over 15, it's 15 over 7. And now we just multiply this just like we did. So we can cancel common factors first. 15 divided by 3 is 5 over 1. And now we can multiply. So 2 times 5 is 10. 1 times 7 is 7. Let's write this as a mixed number. We end up getting 10 divided by 7 is 1 and 3 over 7. Okay, and for the next one, we have 6 over 7 divided by 18. So once again we see division, so it's keep, change, flip. Keep the first one the same, change to multiplication. When we reciprocate or flip 18, we have to remember that a whole number technically has a 1 in the denominator. So the reciprocal of 18 is 1 over 18. Okay, so once we have that, now we can simplify. 6 and 18 have a common factor of 6. So they cancel and we get 1 and a 3. So 1 times 1 in the numerator, it's 7 times 3 in the denominator. We get 1 over 21 is our answer. That is not an improper fraction, so we leave it as is. Last one here, we have 2 2/5 divided by 3 1/3. So we have mixed numbers, so we have to change these to improper fractions. And 2 2/5 becomes 12 over 5. And 3 1/3 becomes 10 over 3. And keep, change, flip. Keep the first one the same. Change to multiplication. Reciprocate or flip the second one. And now we can cancel some common factors here. So we have a common factor of, looks like 2 with the 12 and the 10. So divided by 2 we get 6. Divided by 2 we get 5. And it looks like we can just multiply right across right now. So we end up getting 6 times 3 is 18. 5 times 5 is 25. And it cannot be simplified, so 18 over 25 is our answer. Okay, for the next thing here, the way that we're going to be converting fractions to decimals is we can start with a fraction and then we can divide the numerator by the denominator. However, sometimes a decimal can be an irrational number, meaning the number goes on forever and it does never repeats. So sometimes it is actually better to keep the number in fraction form so we don't have to round it. But for these examples, they're not going to be irrational numbers, so we won't run into that problem. So for this first example, let's convert 5/8 to a decimal. So converting this to a decimal, 5/8 literally means 5 divided by 8. So we're going to divide. Numerator divided by denominator. So when we are dividing these, the 8 clearly does not go into the 5. So what we have to do is we have to place a decimal point down to the right of 5. And I'm just going to extend this bar a little bit. And then we also have to place a decimal point straight up in our answer, in our quotient. And I'm going to put a 0 in front of it just to draw attention to the fact that there's a decimal point there. So the reason why we do this, once again, is because 8 did not go into 5. 8 was larger than 5. So by doing this, we can say 5 is the same as 5.0. And now we can think of how many times does 8 go into 50. Well, 8 goes into 50 6 times, so we would put a 6 right above where the 50 would end, right above it. 6 times 8 is 48. And then we subtract, this as if it's 50 minus 48, and we get 2. So 8 does not go into 2. So what we can do is we can keep on adding zeros, and I'm going to bring that 0 down now. So now this is saying how many times does 8 go into 20? That would be twice. 8 times 2 is 16. 20 minus 16 is 4. And I believe we can do this one more time now and add one more 0 at the end. So we're not changing the number 5. 5 is the same as 5.0, which is the same as 5.000. So bringing down the 0 gives us 40. 8 goes into 45 times, and 8 times 5 is 40, so that gives us a remainder of 0. So this actually ended up giving us a nice answer of 0.625. Okay, and then for the next one we have 2/3. So 2/3, once again, we have to divide. So it's going to be 2 divided by 3. And once again, 3 does not go into 2, so we're going to put 0.0. And we're going to put a point here, put a 0 in front of it to draw attention to it. So 3 goes into 20 6 times. 6 times 3 is 18. Subtract, we get 2. Same concept as last time, add a 0 at the end, bring it down. And then we have 20 again. So 3 goes into 20, once again, 6 times. And multiply 18, subtract, we get 2. So if you recognize, this was actually going to keep on going on forever and ever. the same pattern. 20 minus 18 is 2, 20 minus 18 is 2. So we're going to keep on getting a 6 up in that numerator, or sorry, up in that quotient. So whenever that happens and it's repeating, so we get 0.6666666 repeating, dot, dot, dot. What we could do to signify that it's repeating is put a bar over it. So this is the same as 0.6 with a bar over it, which means 0.6 repeating. So this is not an irrational number. This is a rational number. It goes on forever, but since it repeats, that does not mean that does mean that it's rational. Okay, so that's just some shorthand for that one. And let's do one more here, 2 3/5. So we technically have two options here. We can leave this as 2 3/5 and just divide 3 divided by 5 and then add that to 2. Or we can take this and we can write it as an improper fraction, which is what I'm going to do just because that's what we've been doing. 2 3/5 is an improper fraction. 5 times 2 is 10 plus the 3 is 13. That gives us 13 over 5. So now let's do this how we were just doing it. And let's divide 13 divided by 5. So 5 goes into 13 twice. And 2 times 5 is 10. We subtract and get 3. And 5 does not go into 3 anymore because 3 is smaller. So this is when we can put the decimal, bring down the 0, and do what we were just doing. 5 goes into 36 times. 6 times 5 is 30. We subtract and we get 0, so we're actually done. So this actually equals 2.6. So if we did this without changing it to an improper fraction, 3/5 would end up giving us 0.6. We would just have to add that to the whole number 2 out front and get 2.6. So the next thing here is adding and subtracting decimals. So the one thing to remember here is when we're adding or subtracting decimals, when we're setting this up like a column, we have to line up the decimal points because it'll line up the place values properly. And we have to remember that we're allowed to use zeros at the right end of a decimal number to fill in the open gaps. And when we're done adding or subtracting, we just bring the decimal points straight down. So let's do this first example. Let's add 1.56 plus 8.2. So when we're setting this up, let's set it up like 1.56 plus 8.2. So we lined up the decimal point correctly here, but we can fill in a 0 at the end of 8.2 to make sure that they have the same number of place values. And now we just add straight down. 6 plus 0 is 6. 5 plus 2 is 7. 1 plus 8 is 9. So this gives us an answer of 9.76. Okay, and then for the next one here, 200 minus 37.69. So we do have to remember how to do borrowing, or if we were adding, if we got a number greater than 10, we have to remember how to take care of that. So 200 minus 37.96. So setting this up, it'd be 200 minus 37.69. And for 200, we can put 0.00 in to line it up correctly. And subtracting this now, starting with the right, just like we just did, we have 0 minus 9. So what we have to do here is borrowing. We would have to go to the number to its left and end up making it a 10 here. But that one is also a 0. So we have to go to that next one, which is also a 0. So we have to keep going until we get to 2. And we have to take 1 away from 2, which gives it a 1. And now what we have to do is make all of these other ones a 9. Except for that last one, which is the reason why we did it. That one becomes a 10. So that's borrowing. So now we can do it just like we did it before. 10 minus 9 is 1. 9 minus 6 is 3. 9 minus 7 is 2. 9 minus 3 is 6. And then 1 minus 0 in this case would be 1. Okay, so this answer ends up being 162.31. Okay, next thing for the multiplication of decimals. So to multiply decimals, what we're going to do is we're going to ignore the decimal points. So we're going to pretend like these are whole numbers, and then we're going to multiply them together. And then we're going to count the total number of decimal digits, which is the digits to the right of the decimal point in the original two numbers. We're going to add those together, and that's going to tell us how many decimal digits should be in our answer. So we're going to move the decimal over for our final answer, that many decimal points. So let's see this first one, 304.2 times 0.16. So first what we're going to do is we are going to ignore the decimal point. We're going to pretend like the first one is 3042, and then we're going to pretend that second one is 16, and we're going to multiply these just like we kind of were adding it in that column fashion. So this one, we have to start with that 6, and we have to multiply that 6 throughout that first one, starting on the right. So 6 times 2 is 12. So that would be 2, and then carry that 1 over here. 6 times 4 is 24, plus that 1 is 5. So put the 5 right there. Carry the 2 up here. 6 times 0 is 0, plus the 2 is 2. And then 6 times 3 is 18. Okay, so that's multiplying the ones digit. So now we can get rid of all that. Now we're multiplying this 1, which is the tens digit. Since that's the tens digit, what we have to do is put a 0 here, indicating that we're starting with the tens digit. So 1 times 2 is 2, 1 times 4 is 4, 1 times 0 is 0, and 1 times 3 is 3. And now we take these and we add them up. So we get 2 plus 0 is 2, 5 plus 2 is 7, 2 plus 4 is 6, 8 plus 0 is 8, 3 plus 1 is 4. So we get that big answer, but we need to remember that we were multiplying decimals. This one, we had 1 decimal point. This one, we had 2 decimal points. So that is a total of 3 decimal points. So we have to, 1, 2, 3, have 3 decimal points as our answer here. So that's going to be a final answer of 48.672. So we had 3 decimal points for this final answer based on the original two decimal numbers. Okay, let's do one more. 250 times 4.5. So once again, let's ignore the decimal and do 250 times 45. So multiplying that 5 throughout, 5 times 0 is 0, 5 times 5 is 25, put the 5 down, carry the 2. 5 times 2 is 10, plus the 2 is 12. Okay, so we're done with the first one. Now we have to multiply that 4. 4 times 0, so once again, this is the tens place value, so we have to put a 0 for the ones place value. So now 4 times 0 is 0. 4 times 5 is 20. We put the 0 here, carry the 2. 4 times 2 is 8, plus the 2 is 10. So we get that big number, and now we add these together, and we get 0 plus 0 is 0, 5 plus 0 is 5, 2, 1, and 1. And we had only 1 decimal point in our original numbers here from the 4.5. So that's going to mean we have 1 decimal point in our answer. So our final answer is going to be 1125.0, which I'm not going to write. Well, I'll write it here, and then I won't write it for the final answer, because it is unnecessary to write it. Okay, so that is multiplying decimals. Next for dividing decimals. So with division, we're going to place the decimal point in the answer before we even divide the numbers here. So if the number that we're dividing by, which is called divisor, is a whole number, we're going to bring the decimal point straight up into the answer, which is the quotient. If the divisor is not a whole number, we're going to make it a whole number by doing the following. We're going to move the decimal point over in the divisor to make sure it's a whole number. And then we also have to move the decimal point over in the dividend, the same number of places that we did in the divisor, and then we bring the decimal point straight up in the answer. So our initial goal here is to make the divisor a whole number. So let's divide 106.8 divided by 15. So 15, this is already a whole number. This is the divisor. So we can just go ahead and divide it right away. So it's going to be 106.8 divided by 15. And we're going to bring the decimal point straight up into the answer. And we're going to say how many times does 15 go into 106? It goes in 7 times. So 7 times 15 is 105. We subtract and we get 1. And then we're going to bring down the 8. 15 goes into 18 once. 15 times 1 is 15. We subtract. We get 3. And now we have to add a 0 here at the end. So we can bring that down. And now that makes this number 30. So 15 goes into 30 twice. 15 times 2 is 30. That gives us 0, so then we're done. So 106.8 divided by 15 equals 7.12. Okay, next one here we have 4.856 divided by 0.02. So for this one, the dividend is not a whole number. So what we're going to do is make it a whole number by moving the decimal point over to the right, in this case 2 spots. We also have to do that to the dividend. So the dividend ends up being 485.6 divided by 2. So instead of 0.02, we made it a whole number, and now we're just dividing by 2. So essentially, this is like a fraction, 4.856 over 0.02, and we pretty much just multiplied the numerator and denominator by 100, moving the decimal place over 2 to the right for both of them. Okay, so now dividing this normally here, 2 goes into 4 twice. 2 times 2 is 4. So we subtract that, and that ends up getting us a 0. So we can bring down the 8. We bring down the 8. 2 goes into 8 4 times. 4 times 2, 8. Subtract, we get 0. Bring down the 5. 2 goes into 5 twice. Put the decimal point up there, bring it straight up. 2 times 2 is 4. Subtract, we get 1. Bring down the 6. 2 goes into 16 8 times. 2 times 8 is a nice even 16. Remainder of 0, so we're done. So this final answer is 242.8. Okay, so next for rounding. So sometimes an exact answer is going to have too many digits for a certain situation, so we're going to have to round the decimals. So rounding these numbers is going to give an approximation of the exact number in a more usable form, in a smaller form. So in order to do this accurately, we need to be familiar with these decimal places. So here's an example of a number. Here's the decimal point right here. So the whole part of the number is to the left. The fractional part is to the right, and you can see that these are labeled. The first part to the left is the ones or the units. Then we have tens, hundreds, thousands, 10,000s, 100,000s, millions, and so on. And for the right-hand side, we have, this is where it differs a little bit. We start with the tenths, and then hundredths, thousandths, 10,000s. So notice the TH at the end, and notice that it does not start with a ones. Okay, so these are the place values for a decimal number. And when we are rounding to a certain place value, we have to look to the value directly to its right. If that number is 5 or greater, we're going to round our number up by 1. If it's less than 5 on the right, then we're going to keep our number the same. So for example, let's round 0.237 to the nearest hundredth. So first, we have to find the hundredth. So here is the hundredth, right here. It's the 3. So when we're rounding that to the nearest hundredth, what we have to do is we have to look to the point to its right. Since that is greater than 5, we're going to bump the 3 up to a 4, and that's going to be 0.24. So it's saying that 0.237 is closer to 0.24 than it is to 0.23. So rounded to the nearest hundredth is 0.24. And what we can do here is actually use this approximately sign. It's a wavy equal sign, so that means approximately. Okay, let's do another one here. We have, let's round 5.8395 to the nearest tenth. So here is the tenth units. So we have to look to its right, and that is a 3, which is less than 5. So we're going to keep our number the same, which was the 8. So this is just going to be 5.8. Okay, so that is rounding, hopefully pretty simple. And the next thing is percents. So percents, we can't actually use these in our computation. So when we're working with them, we have to change them to decimals or fractions in order to do computations. So changing percents to decimals is relatively simple. All we have to do is move the decimal point. So when we're going from a percent to a decimal, we have to drop the percent sign and move the decimal 2 places to the left. So doing the first example here, converting 65% to a decimal. So we're going to drop the percentage sign, and the decimal, if it's not written, is always after the number. So we move it 2 to the left. So it goes right over here to the left of the 6, and we get 0.65. Once again, put a 0 in front of the decimal just to draw attention to the fact that it's there. And 0.65 is the same thing as 65%. Percent literally means for every 100. So 100 in terms of decimal movements would be two decimal movements. So that's why we use 2, because it's percent for every 100. Next, for 3.7%, here's the percent, here's the decimal. So we move it 2 to the left. So this time it went to the left 1 spot where there wasn't anything, so we actually have to put in a 0. So we drop the percentage sign and we get 0.037, which was 3.7%. So we had to add that 0 into the left. So now let's go the other direction here, and let's change a decimal to a percent. Once again, pretty simple. All we have to do here to go from a decimal to a percent is we move the decimal 2 places to the right and then include the percentage sign afterwards. So for 0.08 as a percent, we're going to move that 2 to the right, which gives us 8, and then we throw in the percentage sign, so 0.08 represents 8%. And for the last one here, 0.125, we move that 2 to the right, and we get 12.5%. Okay, so it's simple as that for converting between decimals and percents. So for the next thing here for temperature conversions, so we're going to be using two main scales here to measure temperature, Fahrenheit and Celsius. There's also Kelvin, but we're not going to be using that for this one. So here are the formulas for it. We have, if we're converting Celsius to Fahrenheit, we have Fahrenheit equals 9/5 times Celsius plus 32. So right here, whenever you have something written next to something without any operation sign, it's multiplication. So if you didn't want to use 9/5, you could use the decimal form, which is 1.8. So Fahrenheit equals 1.8 Celsius plus 32. If we're going from Fahrenheit to Celsius, all we would have to do for these ones is solve for C, which we won't be doing, but that's just a little algebra there. So we get Celsius equals 9/5 times F minus 32, or Celsius equals F minus 32 divided by 1.8. Whichever one you want to know, they're both the same thing. It's usually a little bit easier using the decimal version if you're plugging them into your calculator. So let's do an example here. So let's convert the following, and let's round to the nearest tenth if necessary. So if we have 37 degrees Celsius, we want to convert that to Fahrenheit. What we're going to do is use the formula F equals 1.8 times Celsius plus 32. So I'll use that 1.8 version instead of the 9/5. It doesn't matter though. So we have 1.8 times Celsius. So what we're going to do is we are going to plug in 37 into C. So that's 1.8 times 37 plus 32. Make sure your order of operations are correct, your PEMDAS, multiplication first. 37 times 1.8. I'm just going to skip doing that. We can probably do that by now. We get 66.6 plus that 32, and we add those together and we get 98.6 degrees. So 37 degrees Celsius equals 98.6 degrees Fahrenheit. And let's do this one, 102 degrees Fahrenheit. Let's find what this is equivalent to in degrees Celsius. So let's use Celsius equals Fahrenheit minus 32 divided by 1.8. Okay, so for this one, we're going to plug in 102 into F. So it's going to be 102 minus 32 divided by 1.8. 102 minus 32 is 70. 70 divided by 1.8. So you could divide this just like we did previously. We end up getting a repeated decimal. 38.8 repeating, which according to the directions it said round to the nearest tenth. That would be 38.88888. So rounding that to the nearest tenth would be 38.9 degrees. So for our final answer, we would get 38.9 degrees Celsius. Okay, for the next thing with ratios, a ratio is just a comparison of two quantities. So for example, the ratio 5 pens cost $1 is a fixed relationship between the number of pens and their cost. And driving down the street, you might see a street sign that says 45 miles per hour. That's a ratio between distance and time. And a ratio is often written as a fraction in order to help us solve certain problems. So all a ratio is a comparison or a fraction. So this brings us to proportions. So proportion is a statement setting two ratios equal to each other. So this concept is super important, setting up proportions. This is how we're going to be solving almost all of our dosage problems going forward after the section. So sometimes you're faced with a drug order that differs from the way that the drug is labeled, and you can figure out the correct amount of drug to be administered by setting up a proportion and solving for the variable, which we'll get into in a little bit. So let's consider this following proportion: 3/5 equals 6/10. So that's a proportion. We have a ratio equals a ratio, a fraction equals a fraction. And there are a couple different ways here that we can show that these are equal. We could reduce or simplify the 6/10 and show that it equals 3/5. Or we could show that 3/5 equals 6/10 by multiplying the numerator and denominator by 2. Or we could change both of the fractions to decimal numbers and show that they're both going to be 0.6. The other way is by cross multiplying. So this way is might be new to you guys, it might not be, but this is the way that we are going to be solving proportions going forward. The principle of cross multiplication says that if two fractions are equal, then their cross products are equal. Cross products are going to be found by multiplying the first fraction's numerator with the other one's denominator. So we're going to do that for each fraction and show that they're equal, and that's going to tell us that these are equivalent ratios. So let's do an example here. So let's use cross multiplication to determine if the fractions are equal or not. So the first one is the one that we just did. 3/5 equals 6/10. So the cross multiplying here is you're multiplying numerators and denominators. So you're multiplying those values. So that would be 3 times 10 equals 6 times 5. Numerator times denominator equals numerator times denominator. So we get 30 equals 30, which is true. So these are equal. So this proportion is true. These fractions are equal. For this next one, we have 7/12 equals 13/18. So once again, we're going to multiply numerators and denominators together. So we're going to get 7 times 18 equals 13 times 12. It doesn't matter which one you put first. You could put, for example, on the left, you could put 18 times 7. It means the same thing because multiplication is commutative. So 7 times 18 is 126. 13 times 12 is 156. So I'm going to put a little X because these are clearly not equal. Okay, so that is cross multiplication. So cross multiplying isn't only used to check if two fractions are equal, it's also used when we're trying to solve a proportion. This means we're going to be given 3 out of the 4 numbers in a proportion, and we have to find the missing number using cross multiplication. So let's take a look at this proportion where x is the unknown number. So x is going to be the variable that we're looking for here. So we have 3/5 equals x over 40. So we're trying to think of what does the x have to equal in order for this proportion to be true. So we're going to do this with cross multiplication. So I'm just going to rewrite the problem here. So we cross multiply, we do x times 5, and then we do 3 times the 40. So setting this up, we get 5 times the x. So when we're writing a number times a variable, just write the number first. So 5x means 5 times x, and that's going to be equals 3 times 40. Okay, so 3 times 40 is going to be 120. And if we are trying to find x here, What we have to do is recognize that this is 5 times x on the left. To get x alone, we have to divide both sides of the equation by 5 to cancel it on the left to get x alone. So we get x equals 120 divided by 5, which is 24. So we get x equals 24. So going back up to the question here, that means 3/5 equals 24 over 40. You could check these in your calculator if you want. You could do 3 divided by 5, see that it equals 0.6. Then you could also do 24 divided by 40 and see that that also equals 0.6. Okay, so here are the steps for solving proportions. What we just did. We're going to cross multiply once the proportions are set up by setting the cross products equal to each other, and then we're going to divide both sides by the number multiplying the variable to get the variable by itself. Just remember your goal is to solve for that variable. So let's do a couple examples here. We have 4 over 10 equals x over 50. So 4 over 10 equals what over 50? What does the x have to be in order for this statement to be true? So we're going to cross multiply. So that's going to be 4 times 50 equals x times 10. But once again, I'm going to write that as 10 times x, 10x. So 4 times 50 is 200. 200 equals 10x. And lastly, we just have to divide both sides by that 10, the number multiplying the variable. So we get 200 divided by 10 is 20. So 20 equals x. And then when you're writing this as your final answer, just write the variable first. So it's x equals 20. So that means that 4 over 10 equals 20 over 50. Do a couple more here. We have 1.5 over 0.6 equals 2 over x. So cross multiply, we get 1.5 times x equals 2 times 0.6. So we get 1.5 times x. So if we multiply, I'm actually going to use parentheses right here instead of the multiplication side just because of the decimal. Looks a little cleaner. I'm just going to skip doing the multiplication. 2 times 0.6, we end up getting 1.2. And then we have to divide both sides by 1.5. Obviously, this is a little bit messier here. 1.2 divided by 1.5 gives us 0.8. So that is just dividing with decimals, which once again we already did. And last one here, we have 2/3 over x equals 20 over 7 divided by 5. So now we have fractions. So it's same concept though. It's going to be 2/3 times 5 equals 20 over 7 times x. Okay, so for the left-hand side, 2/3 times 5. 5 is the same as 5 over 1. So 2/3 times 5 is going to be 10 over 3. And on the right-hand side, we're going to have 20 over 7 times x. I'm just going to write it without the parenthesis now to make it a little cleaner. So what we could do here, instead of dividing both sides by a fraction, instead of dividing by 20 over 7, what we could do is we could actually multiply both sides by the reciprocal of 20 over 7. Okay, so this is so we're not dividing by a fraction. We can multiply by the reciprocal, which is 7 over 20. So if we multiply by, it's going to look a little messy, by 7 over 20, on both sides, what that does on the right hand side, that completely cancels it because 20 over 7 times 7 over 20 is 1. And on the right hand side, we're left with the x. 7 on the left-hand side, 7 over 20 times 10 over 3, we end up getting 7 over 6. So obviously I skipped that step here, so we get x equals 7 over 6, or as a mixed number, that's 1 and 1/6. So a little bit messier, but just remember that technique for that one because that's pretty helpful. And let's just do some problems, some applications using proportions. So we can solve a lot of real-world problems using proportions. So since we already know how to solve them, the kind of half the battle here is going to be setting them up properly. And to do that correctly, it is very good to keep in mind the units when you're setting them up. Make sure that the units are correct. So let's see what we mean with this example here. So if a car can travel 81 miles on 6 gallons of gasoline, how far can it travel on 22 gallons of gasoline? So what we're going to do is we're going to say 81 miles on 6 gallons of gasoline is a ratio. So I'm going to set that up as 81 miles per 6 gallons. So if it's a ratio, we can think of it as a fraction, which I just did. And now we're going to set it up using a proportion. So using the units correctly, the right-hand side also has to be miles per gallon. Miles has to be in the numerator, gallons has to be in the denominator. So that's going to be x miles. We are looking for x, so I'm putting an x for the variable, for every 22 gallons. Okay, so once it's set up right with the units, now we can just do it the same way that we've done it. We can cross multiply, get rid of the units while we're in the problem here. So we're going to have 81 times 22 equals x times 6, or 6x. 81 times 22 is 1,782 equals 6x. Divide both sides by 6. And we're going to end up getting x alone on the right. 1,782 divided by 6 is 297. And that is our answer. Make sure that we have units. That's 297 miles. You can go back, you can check your work, make sure it makes sense, just how we did it in the previous ones. You could divide both ratios using the calculator and make sure they're equivalent. Okay, let's do a couple more here. So Tyler wants to surprise his wife by making breakfast. Looking at the pancake recipe, he sees that 2 cups of pancake mix are needed to make 15 pancakes. How much pancake mix should he use if he only wants to make 10 pancakes? So setting this up, we have 2 cups for 15 pancakes. And we're setting up a proportion now. So now it's going to be cups over pancakes. We are looking for how many cups. So it's going to be x cups over 10 pancakes. How many cups for 10 pancakes? Once again, solve this the same way that we did it. And cross multiply, so we get 2 times 10 equals 15 times x. So we're going to get 20 equals 15x. Divide both sides by 15. And we get 20 over 15 for x. And this will end up being, put it over here, x equals 20 over 15 as a mixed number would end up being 1 and 5/15, which is 1 and 1/3. So it's 1 and 1/3. Can't forget to label it 1 and 1/3 cups. So just a little note here, and this goes for the first example that we did as well. what we could have done is we could have flipped this and did 15 pancakes over 2 cups. So notice that it's flipped, but we would also have to flip it on the other side and say 10 pancakes over X cups. So we could have done it that way. Also, it doesn't matter. You just have to make sure the units are the same on both sides. Okay, let's do one more here. So Jessica and Timmy want to surprise their parents on their anniversary with a dinner. The recipe for lasagna requires 1 2/3 cups of spaghetti for every 5 servings. If they plan on making enough for 12 servings, how much spaghetti sauce will they need? So we're going to have spaghetti sauce and servings as our 2 quantities here. So it's going to be 1 2/3 cups for every 5 servings. And that's going to equal, we are looking for how many cups they need. So X cups for 12 servings. Okay, so we just have to cross multiply once we have it set up correctly with the units being the same on both sides. So cross multiply, we get 1 2/3, use parentheses, times 12 equals X times 5, or 5X. So instead of using 1 2/3, we're going to rewrite that as a improper fraction. 3 times 1 plus 2 over that denominator, that's 5/3 times 12 equals 5X. And that's going to end up multiplying. 12 divided by 3 is 4. 4 times 5 is 20. Okay, so I just did that one without showing my work. I simplified the 12 over 3 as 4, and then multiplied that by the 5 and got 20. And now we can divide both sides by 5, and we get 20 over 5 is 4, and we get X alone, which is what we wanted. So we get X, our answer is 4 cups. So 4 cups for those 12 servings. Okay, so definitely know how to do these proportions, because these are going to be one of the most important concepts for this whole entire class. Okay, so that's it for chapter 1.